In 1950, a Dutch astronomer named Jan Oort proposed something that seemed impossible. A vast cloud of trillions of icy objects surrounding our entire solar system, extending halfway to the nearest star. Nearly 75 years later, despite all our telescopes and space probes, we have never directly observed a single object in the Oort Cloud. Yet scientists are certain it exists. Even stranger, recent data suggests the Oort Cloud isn't just a random collection of frozen debris. It has structure, layers, and boundaries that don't match our predictions. What Voyager discovered at the edge of the heliosphere may be just the beginning. Because beyond that wall of fire lies something far more mysterious, a hidden realm that holds the memory of our solar system's violent birth and may contain visitors from other stars. When the Voyager spacecraft crossed the heliopause and entered interstellar space, scientists celebrated. Humanity had finally reached beyond the sun's protective bubble and touched the space between stars. But that celebration came with a humbling realization. Voyager hadn't really left the solar system at all. Not even close. The heliopause, that turbulent boundary where the solar wind collides with interstellar plasma, lies about 120 astronomical units from the Sun, roughly 11 billion miles. It sounds impossibly far, and by human standards, it is. But the true edge of the solar system, the Oort Cloud, extends to somewhere between 50,000 and 100,000 astronomical units. That's nearly 1,000 times farther than Voyager has traveled. To put this in perspective, if the Sun were the size of a basketball sitting in the center of a football field, the heliopause would be just beyond the goalposts. The Oort Cloud would extend for miles in every direction, far beyond the stadium, encompassing entire neighborhoods. Voyager has barely left the field. This means that, at its current speed of about 38,000 miles per hour, Voyager 1 won't reach the inner edge of the Oort Cloud for another 300 years, and it won't exit the outer edge for approximately 30,000 years. Long after human civilization has transformed or vanished, Voyager will still be crossing through this immense region, drifting silently among objects we've never seen. So what exactly is the Oort Cloud? The theory goes like this. When the solar system formed about 4.6 billion years ago, the planets didn't form alone. The disk of gas and dust surrounding the young sun contained far more material than what ended up in the planets. Much of it was swept up by Jupiter, Saturn, and the other giant planets as they grew. But some objects, icy planetesimals containing water, methane, and ammonia, were flung outward by gravitational interactions with those planets, ejected to the far reaches of the sun's gravitational influence. Over millions of years, these objects settled into a vast spherical shell surrounding the solar system. Unlike the flat disk of the planets, or even the Kuiper Belt, the Oort Cloud is three-dimensional, enveloping the sun like a cosmic snow globe. Scientists estimate it contains trillions of objects, ranging from mountain-sized chunks to bodies larger than dwarf planets. The total mass is uncertain, but models suggest it could be several times the mass of Earth, all scattered across an unimaginably vast volume. Yet despite its enormous size and population, we've never directly detected a single Oort Cloud object in its native habitat. Why? Because they're incredibly far away and reflect almost no sunlight. At those distances, even a planet-sized object would be invisible to our best telescopes. We only know about Oort Cloud objects when they fall toward the sun and become visible as long-period comets. Visitors from the deep freeze, plunging into the inner solar system on orbits that can take thousands or even millions of years to complete. Every so often, something disturbs an object in the Oort Cloud. Perhaps the gravity of a passing star or the gentle tug of the Milky Way's galactic tide, and sends it tumbling inward. As it approaches the Sun, frozen gases begin to vaporize, creating the glowing tail we recognize as a comet. Famous examples include Comet Hale-Bopp, which has an orbital period of about 2,500 years, and Comet Hyakutake, with a period exceeding 70,000 years. These comets are time capsules from the early solar system, preserving materials that have remained frozen and unchanged for billions of years. But here's where things get strange. In recent years, astronomers have detected comets entering the inner solar system with such extreme orbits that they shouldn't exist. Some are moving so fast and on such steep trajectories that they can't be explained by the standard Oort Cloud model. One of the most famous is Oumuamua, discovered in 2017. Initially thought to be a comet, it showed no tail or outgassing despite passing close to the Sun. Its elongated shape and strange acceleration as it left the solar system sparked intense debate. Was it a natural object or something artificial? While most scientists settled on a natural explanation, perhaps a fragment of a shattered planet or an icy body venting invisible gases, Oumuamua's behavior hinted that our understanding of distant solar system objects might be incomplete. Then, in 2019, astronomers discovered Comet Borisov, confirmed to be the first interstellar comet, an object from another star system passing through ours. Its chemistry was similar to solar system comets, but with differences suggesting it formed in a different stellar environment. These discoveries raise an unsettling question. How many objects in the Oort Cloud aren't ours? How many were captured from interstellar space or stolen from other stars during close encounters billions of years ago? Some models suggest that up to 10% of Oort Cloud objects could be interstellar in origin, meaning our solar system's outermost region is a Hun-He of native and foreign debris, a graveyard of icy wanderers from across the galaxy. But the Oort Cloud holds another secret, one that's even more disturbing. In the 1980s, paleontologists noticed something odd in Earth's fossil record. Mass extinctions seem to occur in a cyclical pattern, roughly every 26 to 30 million years. Dinosaurs, trilobites, and countless other species were wiped out in waves, and the timing was suspiciously regular. Some scientists proposed a radical explanation. The Sun might have a companion star, a dim, distant object orbiting far beyond the planets. Every 26 million years, this hypothetical star, nicknamed Nemesis, would pass through the Oort Cloud, gravitationally disturbing thousands of comets and sending them hurtling toward the inner solar system. The resulting bombardment would trigger mass extinctions on Earth. Searches for Nemesis found nothing. If the Sun has a companion, it's either too faint to detect or doesn't exist. But the idea that the Oort Cloud could be periodically disturbed, showering the inner solar system with comets, remains plausible. Stars do pass relatively close to the Sun occasionally, within a light year or so, and their gravity can disrupt distant orbits. The last known close encounter was with Schultz's star about 70,000 years ago, which came within 0.8 light-years and likely sent ripples through the Oort Cloud. Any comets it disturbed are still on their way inward. Recent computer simulations have revealed something even stranger about the Oort Cloud's structure. Instead of being a smooth, uniform shell, the cloud appears to have layers and clumps, regions of higher density separated by relatively empty voids. These structures might be remnants of how the cloud formed, shaped by the early solar system's chaotic dynamics. Or they might be evidence of external influences, stellar encounters, galactic tides, or even the gravitational pull of a large, undiscovered planet in the outer solar system. The hypothetical Planet 9, if it exists, would orbit well inside the Oort Cloud's inner edge, its gravity sculpting the distribution of objects there. Some scientists have even proposed that the Oort Cloud might contain rogue planets, worlds ejected from the inner solar system during its early turbulence or captured from interstellar space. These would be dark, frozen worlds, radiating no light, detectable only through their gravitational effects. If such a planet exists, it would be closer than any star but utterly invisible, a phantom world hiding in the solar system's outermost darkness. Now, connect this to what Voyager found at the heliopause, a superheated boundary where the solar wind collides with the interstellar medium, creating a protective shell around the Sun. That shell extends about 120th AU, but the Oort Cloud begins roughly 2,000 AU out and stretches to 100,000 AU. This means the Oort Cloud exists primarily in interstellar space, beyond the Sun's protective bubble, exposed to cosmic radiation, galactic magnetic fields, and the relentless tug of nearby stars. Objects there are barely bound to the Sun, held in place by the faintest gravitational thread. A passing star, a rogue planet, or even a massive molecular cloud could strip away portions of the Oort Cloud, scattering its contents into the galaxy or sending them plummeting toward the inner planets. Dr. Nathan Kaib, a planetary scientist who studies the Oort Cloud's dynamics, describes it as a fossil record of the solar system's formation and its interactions with the galaxy. Every comet that falls inward carries information about where it formed, how it was ejected, and what forces have shaped its orbit over billions of years. By studying these comets, scientists can reconstruct the early solar system's architecture and track stellar encounters that occurred millions of years ago. But here's the unsettling part. We've only sampled a tiny fraction of the Oort Cloud. The comets we've observed represent maybe 0.21% of the total population. The rest remains hidden, unknown, and potentially full of surprises. What if there are objects in the Oort Cloud that challenge our understanding of planetary formation? What if some of them are active, venting gases, or even harboring subsurface oceans kept warm by radioactive decay? What if, billions of years ago, a passing star injected something into our Oort Cloud? A rogue planet, a massive comet, or something we don't yet have a name for? There's also the question of what happens to the Oort Cloud over cosmic timescales. As the Sun orbits the Milky Way's center, it moves through different galactic environments, dense star clusters, spiral arms, and relatively empty voids. Each environment exerts different gravitational forces on the Oort Cloud, compressing it, stretching it, or stripping away its outer layers. Some models suggest that the Sun has lost a significant portion of its original Oort Cloud over the past 4.6 billion years, with objects gradually peeled away by stellar encounters and galactic tides. And then there's the future. In about 4 billion years, the Milky Way will collide with the Andromeda Galaxy. During this slow-motion collision, stars from both galaxies will pass through each other's neighborhoods, gravitationally disturbing Oort clouds and sending comets flying in all directions. Our solar system might capture objects from Andromeda's stars, while our own Oort cloud might be partially stripped away, its contents scattered across the merging galaxies. For now, the Oort cloud remains one of the solar system's greatest mysteries, a vast, invisible frontier that we know exists but have never seen. Voyager's discovery of the heliopause was a monumental achievement, proving that we can reach the boundary between solar and interstellar space. But beyond that boundary lies the Oort Cloud, a realm so distant and dark that it will likely remain unexplored for centuries. NASA has proposed future missions to study the Oort Cloud more directly. The interstellar probe concept would travel 3 times faster than Voyager, reaching 500 AU in 50 years and potentially detecting Oort Cloud objects directly through their gravitational effects on the spacecraft's trajectory. Such a mission could also study how the heliosphere's structure changes at greater distances and how the Sun's influence finally fades into the true interstellar medium. But until such missions launch, the Oort Cloud will remain a phantom, a theoretical construct supported by indirect evidence, mathematical models, and the occasional visitor that falls inward and lights up the sky. It's a reminder that even after centuries of astronomy, our own solar system still holds secrets. We've mapped distant galaxies, detected exoplanets thousands of light-years away, and peered back to the universe's earliest moments. Yet the outer edge of our own cosmic neighborhood remains largely unknown. Voyager found fire at the heliopause, a wall of superheated plasma marking the Sun's influence, but beyond that fire lies ice. Trillions upon trillions of frozen relics, drifting in the darkness, holding the memories of our solar system's birth. And somewhere in that icy shell, perhaps, are answers to questions we haven't even learned to ask yet. For all that we've learned, one question remains. What's waiting in the Oort Cloud that we haven't imagined? Thanks for watching another episode. While you're still here, make sure to click the video on your screen for more quality content.